Hello, everyone. Welcome to our webinar on passive optical networking. If you're on the West Coast, good morning. If you're on the East Coast, good afternoon. We're just going to wait a couple of minutes before everyone gets logged in, so please stand by. We'll get started in a little bit. All right, perfect. It looks like we're good to go. We're going to get started here. So again, welcome to our webinar about passive optical networking. There we go. So before we get into it, we want to do a poll here. There's going to be two options. We just want to get your feedback. What do you think is more expensive to connect a single edge switch? Is it going to be point-to-point with fiber, or is it going to be passive optical networking? So think about this. All we're looking for is from the head end to a single edge switch. Which one do you think is more expensive? Go ahead and put in your answers. This is a bit of a trick question as we kind of discuss this, Eric. I'm curious to see what people say. So jot those down. Eric, what are you thinking here? It can really go either way. We didn't really determine length. We didn't really determine what kind of edge switches we're using, if they're managed or unmanaged. But in general, what do we see here with the results that we usually use with point-to-point or PON?
Well, Shane, if you're restricting it to a single edge switch, so you just have one core and one edge,
Yep.
then I mean, really, that is the definition of a point-to-point. So for that one, can't imagine passive optical networking being any better for that specific case.
Yeah.
But as soon as you start adding more, okay, so it looks like, looking at the results, most people were not tricked by you misleading them with the question. But yeah, so point-to-point would be better for single edge switch, of course.
Yeah.
It's as you start to add more switches that the passive optical networking could help.
Yeah. Perfect. Okay. Good introduction. Thanks for explaining that. We'll jump back in the slides here.
Yeah.
Excellent. Okay. Moving forward. So with us today is, sorry, I lost static. There we go. With us today is a good friend of ours. His name is Mike Smith. He is the vice president at Whitespace. He's been in the real estate technology industry for about 15 years. He launched Whitespace in 2015 to provide a single source for building technology solutions for the real estate market. Served as a co-chair at IBCon and was on the advisory council for Realcomm and broadband communities. Mike, am I missing anything else? Your golf handicap, your favorite soap opera?
Yeah,
anything else you want to add?
Don't ask me to play golf. I'm horrible at golf. But no, that was good. I appreciate it. You guys good? Can you hear me?
Yep.
All right. So no, that was good. That was fine what you said. I appreciate it.
Yeah, so why don't you please, tell us what Whitespace does, what your vision is, and what you guys do.
Yeah, so the name Whitespace is kind of, we started it with this idea that in real estate, especially new development projects, there's this area that within the project that's not the brick and mortars, it's not the furnitures and fixtures and equipment, and it's this gray area that typically there's no budget, there's no authority, and there's no strategy, right? So they wait till they get to the end of the project and they're like, hey, we forgot to do this, or how are we going to get internet to our buildings? So what we try to do is we try to close that gap, and we don't sell anything. Our goal is to be an extension of the owner or the developer to make sure that they're thinking through technology networks, building networks, the proper way and have the right infrastructure in place.
Excellent. So kind of the unmeasurables on paper, but what builds up over time with regards to efficiency of the building.
Correct. Yeah, and you know, if the things you forget, it can cost you double sometimes to go back and try to add those. Now you're ripping out walls. You're making sure you don't have the right room sizes, or they're too far away because you're using traditional infrastructure, which I think we'll get in. So yeah, we try to close that gap and cover that gray area.
Absolutely. Okay, and with me as well is Erik Haberger. He's our Director of Sales here at Optigo Networks. My name is Shane Tacker. I'm the Account Manager here at Optigo Networks. I will be playing your host today. So let's get started. So we hopefully read the title and the email. So here is to discuss passive optical networking. But more importantly, we want to cater this discussion towards intelligent buildings and quote-unquote operational technology in these intelligent buildings. So as we go through this, we'll start with the history of PON. We're gonna really see where it came from, the complexity and the sophistication of passive optical networking when it was first created. But as we get going, we'll see how it really caters and offers a very compelling solution specifically for intelligent buildings. So, Mike, there's 3 verticals where you have actually deployed passive optical networking. It looks like a couple malls and a multi-family building. So why don't you touch base on the verticals, kind of go into depth of these 3 projects, how big they were, where they're located. So go ahead and kind of elaborate on those 3.
Yeah, so we've used this technology in multiple places. These are kind of the 3 latest. And if you know retail malls, whether they're a lifestyle center, outdoor or indoor, you have fairly long distances for the mall. I mean, some of them can run close to a mile long, and your traditional infrastructure wouldn't work with those. So as we went to retrofit or change out the existing building infrastructure, we had issues with distance using traditional copper. So to get IP cameras to a certain location, we actually had to create separate rooms, air condition them, and run those because of that less than 300 foot distance with Cat5. And so, as well as the 3-story walk-up that you see on the right-hand side with your project in Denver, we had some complexities, and a lot of it came down to cost to connect multiple buildings with the same, whether it was security systems or energy management systems. So for those, the PON technology really worked for us, reduced the overall cost, increased efficiencies, allowed us to monitor different devices, which I think you guys will go into. But it was a very effective solution. As these malls in particular are existing, getting into certain locations and back of house where there's not rooms, it just made sense to try to use that technology.
Yeah, great. Just a reminder to the audience too, this is being recorded and you can ask questions. There are going to be polls which you can participate in, but feel free to put some questions in the chat box and we will answer those. Okay, so diving into what we see today on current technologies, we have home run, we have a lot of active daisy chains. So Erik, why don't you explain to the audience the difference between these 2 and where passive optical networking can have an edge?
Sure. So if we look at a traditional point-to-point fiber architecture, this is typically done with multi-mode cable. It's typically done, it's sort of, with each point-to-point, you're going to have actually 2 fibers, one for the TX and one for the RX, so your fibers will be run in pairs of multi-mode fiber, and any topology you can create has to be based on the rule that you have a line going from one switch to another switch, and that's it. When we move over to the right side with passive optical networking, we introduced a concept of a passive splitter, so you can have a fiber coming in and more than one fiber coming out. Right away, you can see that this enables you to do different types of architectures, point to multi-point, star, tree, as well as passive daisy chain. The big difference with a passive daisy chain versus an active daisy chain is that you avoid that cascade failure effect, where one switch can take out any switch, all the other switches down the line, like a string of Christmas tree lights.
Yeah, and now for passive optical. Sorry, go ahead. Were you saying something?
The tree is exactly what we did on these malls and these lifestyle centers, right? We didn't want to have to create from the core multiple rooms, so that's exactly what we did. We ran some fiber out to an extension pretty far away from the core, And then we use the splitters that you mentioned to then go out to the edge devices. For, in this case, was a camera. The model that I'm thinking of was a camera implementation. So that's exactly right there. That tree form, the tree model is exactly what we used to reduce the cost for our project.
Yeah, and I think you can do some hybrids of those. So you can start off with sort of a tree, and then each branch of that tree can become a passive daisy chain. So you can have multiple leaves, so to speak, along each branch of that tree, which works. You know, you split it, you go in a wall, as you mentioned, like you have your north, south, west wings, and then you can run a passive daisy chain along each wing, which is a pretty effective topology for that particular type of building.
Yeah. Now, are we seeing two fibers here? Are we seeing TX and RX for passive optical networking?
No, that's a good point. So with the passive optical networking, not only can we have a more efficient layout in terms of how we run the fibers, but instead of running two separate strands, one in each direction, we can actually put both directions on the same strand using a different wavelength for one direction and the other. So, right off the bat, 50% right off the bat, saving on fiber, 50% on terminations and everything, and that's before we even get into the splitting, which, as you can see from looking at the diagrams, is going to save you additional depending on the layout.
Yeah. Okay. History of PON. Who is the genius that came up with passive optical networking? Why did they do it? And where is it sort of going now?
Okay, so if you go back to fiber, originally fiber was a point-to-point technology, and it's like, you know, I'm going to run a fiber from New York to London under the ocean, right? That's sort of the original application, right? And then it got, you know, deployed more and more and more, and then eventually people thought, hey, I want fiber to the home, right?
Yeah.
So when we get into fiber to the home, if I'm just going to jump back to this slide here, if you were to build, let's picture a block with 50 houses running down the block, right? You want to build fiber to the home network. Now, if you use a home run, you have to use 2 fibers from the central office to every single house, right? And then if you use an active daisy chain, then one person doing something stupid in their house takes down the whole block, right? So you can see why the passive daisy chain was developed for exactly this purpose, and that's really where the whole motivation to develop PON came from.
Yeah.
So it started from a carrier fiber to the home market, and now it's just starting to be deployed in other types of networks as well.
Sure.
And this concept called passive optical LAN is a passive optical local area network, and that's where these benefits can be applied outside of the carrier market.
Yeah, sure. When it was developed for a carrier market, I'm sure the core switch was as big as a fridge. It cost $1 million back then. So I'm sure that's where we get the misconceptions of how expensive and how complex PON actually is today.
Yeah, well, it's just like fiber itself. I mean, the first point-to-point fiber was incredibly costly and, you know, huge, complicated equipment, and now it's been, you know, democratized to the point where anyone can plug in a point-to-point fiber. PON is following that same trend, right? So now PON is easy to deploy with some new equipment out there.
All right, it looks like we have a question. So how are collisions avoided when doing the passive daisy chain if you are doing channel multiplexing with only 2 frequencies for TX and RX?
Okay, that's an excellent point. So on the upstream downstream, there's wavelength division multiplexing.
Okay.
In terms of within that direction, how do we split the traffic between the different nodes? That is going to be done with time division multiplexing. Yeah. So it's a centrally controlled sort of master of operations, and it's a time division multiplexing on a request basis, which really is a little light equivalent of raise your hand if you have something to say. And also when there's a broadcast or when there's a message being sent downstream, it's like this message is for you. Here it is, and there's some encryption on that, so only the designated receiver can actually listen to the message.
Okay. All right, good question. Thanks for that.
Yeah, excellent.
So we have different types: EPON, WDM, which honestly I don't even know the acronym for. So touch base with all three.
Yeah, very quickly.
The popularity, what you see happening a lot.
Sure. GPON, the original passive optical networking based on a technology called ATM. ATM is pretty complicated, and it involves splitting packets up into little tiny what's called cells of 63 bytes, sending them all across, and then putting them all together at the other end. It works pretty well. It was developed more for voice circuitry, but it's really expensive because the hardware to take those Ethernet frames apart and put them back together gets costly. EPON is a native Ethernet version, which is really designed for all data networks. The frame comes in, however many bytes it is, it goes across the fiber as is, and is taken off with no taking apart and putting it back together. Because you're not doing that, there's a significant savings in the cost. So this is far superior for data networks.
So is this considered layer 2?
Yeah, they're all layer 2 technologies. Okay. Whether you take it apart or put it back together, doesn't matter. It's still layer 2 technology. So the WDM, which stands for wavelength division multiplexing, this actually is used for both GPON, for EPON, and other types of carrier networking. It's just another technology. So they're all considered forms of wavelength division multiplexing.
Okay. Okay, so here we have the overview of passive optical networking. So we have our OLT, which is our head end. We have our ONE, which is our edge switches, and in between we have splitters. Mike, why don't you sort of touch base and what were the three main points where you saw passive optical network? You said, yes, I need to adapt this technology and deploy these in my new projects.
Yeah, so if you look again at the mall scenario that we kind of talked about, we would have the core switch or OLT in like the main telephone room or wherever the head end equipment would go, right? And then this is kind of where the magic happens with the product is, we would need to then maybe run only 2 cameras to the furthest point of a mall, of the mall, right? So it could be close to a mile away. Well, why spend the money on a 24 port edge switch for 2 devices, right? So what we did is we used this exact topology and we put a smaller device way out, in whether it was in like a NEMA enclosure or whether it was actually somewhere on the roof, believe it or not. And then we extended the Cat5 very short distances to the cameras to power them. So the topology here shows that, hey, look, you can get to these areas of a building, and whether it's for security or whether it's for Wi-Fi or something like that, without having to create these new rooms. In real estate, everything is rentable square footage. So an owner does not want me to take out, rentable square footage to put in one little switch to run some cameras. So, the splitters, we actually were able to put up in ceilings, right? Because there's no power going to them. So it didn't have any code issues putting them above, the drop ceiling or putting them on the side of a wall. So getting to the different pieces of equipment, extending that fiber to these base building devices, this is where the cost can tremendously drop down to do that. And I think that's the biggest misconception of PON. As you look at, you mentioned AT&T and Verizon, right? Those are big telcos, and they have the capital to do that to these projects. Where my shameless plug for Optigo networks, but it was so cost effective to actually run this. It was actually cheaper than going to traditional infrastructure with using whether it was HP or Cisco switches.
Okay.
Yeah, that's a good point. I mean, just making sure that PON does not mean rack-mounted equipment, right? With those splitters, some of them are the size of a credit card, some of them are the size of a lighter, right? We've seen them being Velcroed on, we've seen them being screwed to the wall, we've seen them just sort of been tossed into a wall, as well as some of the smaller, like that 8-port that you mentioned could just be screwed to a wall as well. So by no means does this mean installing a 19-inch rack and running, you know, all that kind of overhead.
So Mike, real quick, with regards to the malls, you started that entire network from a single strand of single fiber, correct?
Yes, there was an existing network in the building, right? But it wasn't. It was an old building. It wasn't in good enough shape to actually expand to add multiple devices on there. So yes, we ran a single strand, very small. You know, we happened to have some conduits going back of house. We pulled it in some cases. We were able just to do it above ceiling, and then we went to the splitters. Yes.
Awesome. Yeah. So we ran into a very unique comment the other day when we first spoke with regards to retrofitting. Okay, cool.
Yeah. So our little fairy has brought us a splitter. So
yeah,
we have right here. As you can see with my hand, that's the size. So it's about the size of maybe a credit card, and in terms of the thickness, it is maybe about a 1/4 inch or so. You could bolt it to the wall. You could just put the Velcro. The weight is incredibly light, so mounting it is really not an issue at all. And then it comes with these pre-terminated endpoints. So when you make your connections into your edge switches or into the ongoing fiber, it's just plug and play with a SC UPC connector.
So what's in here? What's making this magic happen?
So where do you plug in the power?
For me, it looks powerless.
Yeah. So there's no batteries, no microchips, no moving parts, no power, no heating or cooling requirements, no ventilation. I like to say you could put this inside a block of concrete, and it would work no problem.
Yeah. Another unique thing about passive optical networking, because if you're starting with a single strand of fiber, let's talk management. Because normally with home run, you have your edge switches. You have 100 edge switches. Therefore, you have a spreadsheet of 100 edge switches when they need to be checked. So with passive optical networking, correct me if I'm wrong, but all the traffic comes into a single fiber. So that's got to make management much easier.
Yeah, well, I mean, management is somewhat separate from the actual physical topology, but the point that you bring up very well is that with passive optical networking, there is some OAM, operation, administration, and maintenance capability built into the protocol itself, right? So with a point-to-point fiber, it's essentially just a connection, that's it. With passive optical networking, when I plug in that connection, not only am I getting just a data connectivity, but there is also a registration process that happens. So when I plug, because it's part of the protocol, right? So when I plug it, and because again, think of what this was designed for. It's designed for plugging in boxes in people's houses, right? So you're going to put a fiber to the house. You're going to have a box in that person's house. That has to be easy to manage, right? Because you can't, if you send a truck to someone's house, that costs a lot of money, right? And with the number of them, they have to be plug and play. The management has to be done automatically with the device registering with the head end, and then all of the management being able to be done from a centralized location, right?
Now, Mike, from a management perspective, how valuable is that for, say, your mall or your multi-tenant? How valuable is having that management and maybe not spending as much time for troubleshooting or configuring?
But I think it's the interface, especially the one that Optigo has, allows you to tell exactly where that device is and what it is. Even to the point where it tells you energy management of that device, right? So you can see how much energy it's pulling, which in some cases could tell you that a device is failing. But it's not, it's a little different mindset than, hey, what's the IP address of that device? You know exactly where it's connected based on, how it's, where the edge device is and what it's connected to. And So that, that's important. That's critical for whether it's a facility manager or an IT person that's managing that building. And the other thing I wanted to add about your splitter conversation, just to add on to, is that splitter can be changed. So if it's a 1 to 4 fiber, it can go 1 to 8. It's very scalable with your building network, and it's very easy and cost effective to change that out on the fly, and you can expand that where, downstream, so to speak, with that splitter. And that's really where I think the building owners will start to, if they haven't already see the value of PON and what they're trying to do and connect these devices.
Yeah, we have a question that actually transitions nicely from that. So with these splitters, yeah, they're great, they're amazing. There's got to be some sort of limitation. So the question is, what is the attenuation loss or insertion loss for each splitter, which correlates to how many meters of fiber cable? So what kind of limitations are we talking about with regards to splitting?
Okay, so so basically, when you're dealing with PON, you're dealing with an optical budget, which is a number of dB. It's about 30 dB that you can afford to lose over the distance from the core switch to any edge switches. Now, if anyone's worked with coax before, they know the dB math. So if I do a 1 to 2 split, which is 50-50, I'm going to lose about 3 dB. The math for fiber splitting is exactly the same as coax splitting. So if I do a 1 to 4, I'm going to lose about 6 dB. I can also do asymmetric splitting that one way loses less dB and the other loses more. So essentially, if I'm not going to go through all the math here, but I'm just going to say it's exactly the same as coax splitting math. With regards to the second part of the question, which is how many meters of cable, so this is a real important thing. This is using single mode cable. So the losses of single mode fiber are measured in the dBs per kilometer, not the dBs per meter. So with OS2, which is pretty much standard, I don't think you can even buy OS1 anymore. It's 0.4 dB per kilometer, right? Okay. So that's going to be 1 dB per mile, right?
Yeah.
Which is pretty incredible.
Some pretty minuscule.
Yeah. So honestly speaking, when we do a design for a building or campus, we don't even really calculate the dB per meter, unless we can see like, okay, this is going to be like 4 miles or something, then we'll factor in the dB loss, but it's not even a factor. It's really just the splits. The other thing that you do is when you do a connector, so if I have to connect these together, there's a little bit of a loss there. It's about 0.2 dB, but if you're doing a bunch of those can add up.
Correct. Apparently people cut out on the last bit of the question. Talk again about the limitations, how many times we can split these. So each splitter has a certain dB loss. You were talking about coax again. Sorry, go ahead and just repeat yourself because I know.
Sure. Yeah. Very quick summary on that. There is a loss when you split. So a 1 to 2 split will give you about the 3 dB loss. 1 to 4 would give you 6 dB. 1 to 8 would give you 9 dB. It's exactly the same math as coax splitting. And you have a dB budget to work with in passive optical networking of about 30 dB. So right away I can see if it's a 1 to 2 split, I can split it 1 to 2, and then that 1 to 2, and then that 1 to 2 up to 10 times, and I can split each one of those 10 times. So that essentially gives 2 to the power of 10 possible ONUs, which is more than the management can handle.
Yeah. So a good passive optical networking company will allow a very good, generous budget. So when Mike discusses things like adding splitters, it's well within the budget.
Yeah, you want to design your network with as generous a budget to allow a lot of tolerance for, maybe the fiber wasn't as good as it cracked up to be. Who knows, maybe they got some dust in it. You always want to allow for these things. And if you make your budget generous enough, there will be a lot of room for expansion, right? So as Mike mentioned the case of taking a 1 to 4 splitter and changing it to a 1 to 8, that's obviously doable, and that would cost you an additional 3 dB.
Yeah.
Another thing you could do, it's not only changing one splitter for another, but you could take an edge switch, right? Unplug the fiber, plug in a 1 to 2 splitter, and have 2 edge switches there, right? Or 1 edge switch there, and then the fiber continues to the next point. So if you add on a remote, like say I have a pole camera in my parking lot, and then I want to add another one, I can literally just add a splitter and put them both there, rather than running a fiber all the way back to the home run.
So Mike, bringing it back to those projects that you did, talk a little bit about how PON is great for convergence, what you put on that network, and it wasn't IT, correct?
It was more OT, right? So I mean, the IT groups were involved, but I consider it more OT. So it was more the building technology. We were not doing voice data video over it. We were not connecting leasing offices, and I think that's a point we need to talk about too. Is that's not what we're talking about here. This is more HVAC. It's more. We actually did Wi-Fi with it, but cameras, access control, and those are really the things that for one of the multifamily projects that we did. Right, we had, I don't know, call it 20 buildings, and we connected them underground, which we were able to use smaller conduit now because we use single mode, 1 strand fiber. Right, so we're not putting big 4-inch conduits in. And so we connected things like the telephone entry system, the management of that. We connected things like the access control system, cameras at each of those locations, any of the other infrastructure in those standalone buildings that needed some type of either internet for the outside world or management. So that was really critical, but again, you can take that so much further, especially as you talked about your budget with bandwidth, right? And it really depends on, is it a 26 meg camera or a 5 meg camera? So, we were fortunate to be able to do that, put this infrastructure in these projects, and really reduce the overall cost while increasing efficiencies.
Yeah. Yeah. Anything else you want to add to the overview of PON? When we speak of bandwidth, what we like to say is 1 gig up, 1 gig down. There is passive optical. Is there passive optical networking with higher bandwidth? I'm assuming for the tele.
Yeah, there's 1 gig and 10 gig available now. But to touch on operational technology, services, and bandwidth required, you bring up a really good point, Mike, where CCTV IP video is really the only operational building technology that consumes any type of significant bandwidth. Things like access control, HVAC, smart power metering, elevators, all these type of things, more on the control side, are incredibly low bandwidth. In fact, we had a bandwidth measurement tool, and we thought it was broken because it was reading 0 for a network that was purely HVAC. But that really provides a good opportunity to consolidate services because you can allocate most of the bandwidth to your IP video, and then you can confidently add any other type of building automation services, knowing that even if you add up all of those, it's not even going to make a difference to your overall available bandwidth.
Yeah. Just give us 1 sec. We're going to switch over to a call item connect because it's better audio.
Excellent. Can everyone hear? Mike, can you hear me?
I can. It's echoing, but I can hear you.
How about now?
That's better.
Perfect. Excellent. Okay. Vanna White brought us another gift again, but nonetheless, we're up and working. So we're going to jump to the poll real quick. We want to see what the audience is dealing with here. So if we throw out the poll real quick, we want to talk about what building architectures do you see passive optical networking fitting in, whether it be upcoming projects or just from these slides at first glance, where you see this PON being a very viable option. So go ahead and put on your answers. Erik, is it something that these 4 options look better than others? Do they all look the same? I guess it all kind of depends on length or
For what's mentioned, we've actually seen on deployments for all of these.
Yeah.
So really, what we're looking for is just what is sort of people's first impression.
Yeah.
You know, we've been talking a lot about the tree topologies here. Those work well for sort of the larger low-rise buildings.
Yeah.
But the passive daisy chain in its purest form is really perfectly suited to a high-rise building.
Yeah, and again, you can't mix those topologies. So again, we were speaking with Mike about his mall where we kind of branched it out into a 1 to 4 north, east, south, west, and then from there we did a daisy chain. Is that right, Mike? Hey, Mike?
Sorry, I was on mute the whole time. I apologize. So yes, but that is exactly the architecture that we did for the project that you're referencing. Yeah, so it was kind of a one-dimensional architecture.
Yeah, exactly. So you can see numerous amount of topologies cascading on from one another, which is the beauty of passive optical networking.
Right.
So poll is in. So I'm glad people are paying attention because mainly all we've talked about are the low rise. So that's with 36. A high rise is another popular one, obviously, with 43%. So again, as we discussed, all 4 of these are definitely viable options for PON. Erik, do you have any comments on the results?
Yeah, no, good to see the high rise in there because it's a really clear application of the passive daisy chain.
Yeah.
Just on the high rise, one thing that we're also bringing to the market is where you can have a splitter where one of these connections can actually just be, like, we can make these with any length you want.
Yeah.
So you can have a splitter where these go to the switches on this floor, and then the input to that splitter can just simply drop down to the previous floor and plug directly into the splitter on the lower floor, and then you can literally just plug the splitters into each other and daisy chain them like that. Wow.
So very few fiber.
Yeah.
Okay, perfect. So if we want to close that real quick, that poll will jump right back into it. So exactly. So with those, what we call them long lead splitters, the need for fiber is very minuscule. Okay, let's do all that. Let's do all that. Let's do all that. Perfect. So with these topologies, let's talk about the 2 that got the most, the highest in polls. So right here we have our high rise on the left side. So what's unique about a high rise is you can split them on every floor if you want. But in this particular scenario, we see them splitting it on every 5th floor. Talk to me about what kind of splitters they're using, how many SFPs they need, and the general topology itself on the high rise. Erik.
Okay. Yeah, so with this is basically a project where there was 2 stairwells that they wanted to cover independently because there was no crossover on the floor. So we did a 1 to 2 at the bottom. We ran the passive splitters up each stairwell. For this one, we went with copper. So we did a switch every 5 floors with fiber, and then each switch would cover that floor and the 2 floors above and below it. Right. So this is a fairly common thing. Some people want to have no copper at all between floors. Some of them will allow some copper between floors to try and trade off costs a little bit. One thing that I want to mention on copper between floors, this can be a bit of an issue in terms of electrical ground isolation. So if you have devices that are plugged in on different circuits on different floors, and then you're having a copper connection between them, you can get into some nasty issues with ground loops and DC offset. It can get kind of nasty. So if you do have a pure fiber between the floor, that gives you complete electrical isolation on each floor, which can lead to a much more dependable, because ground loops can be really nasty to figure out what's going on and diagnose them.
So to touch base on what Mike brought up earlier, when we want to pull maybe 2 cameras to the very end of the building. So let's take this high-rise for example, and we want to add 2 cameras on the 38th floor, which we need an extra edge switch. So rather than pulling a fiber all the way from the core, adding an SFP all the way to the 38th floor, plugging in a new edge switch, what precautions do we take next to allow this to happen?
So actually, for this one, if it's the 38th floor, you have 2 options. You could put another splitter on the 35th floor, run fiber up to the 38th, or assuming that switch on the 35th floor is full, you could actually swap out the switch. So you could swap out maybe an 8-port for a 16-port, for example, and then just run copper because it's only 3 floors up, right? So you have that kind of flexibility. You can trade off on a case-by-case basis, whatever makes the most sense in that particular instance.
So next over here we have a large low-rise. So this would probably most likely be a mall. So Mike, is this sort of what you were talking about when we discussed topologies? We have our core switch a little off to the center. We run it into the center, and then from there we can pass the data chain. Does this look like the topology that you deployed in those malls?
Yeah, it actually is, but because for this was a security project, we didn't have that many switches on there, so we literally ran it to a point, right, and then
okay.
You can make smaller switches, right? So like 2-port here, 2-port there, and so we didn't have to. We kind of eliminated that first ring, if you will, to get out even further, right? And we were probably close to a mile away when we got done with fiber. I mean, it was pretty far.
Yeah. No, exactly. Going off of other topologies that we mentioned in the poll, we have something like a campus, whereas, again, we went more with the tree and then cascading effect, correct?
Yeah.
Other ones we see...
Another one you might want to mention is the ring.
Yeah, exactly.
So you can also do a ring with passive optical networking where you have a head-end unit. You go all the way around, hitting a number of edge switches, and then loop around to a second head-end, which can be used for redundancy. So that's also pretty cool.
Yeah. Excellent. So we'll move on to our last poll here, and this is a big one. We want you, the audience, put down what concerns about PON or what concerns that you've heard of other people speaking of PON when they want to deploy it. Is it some of the ones we've heard of, the misconceptions we hear are it's too complex, it's too expensive, it's not tailored for this industry. Again, it was for telecom, for service providers. Or if you have others, feel free to put them down in the chat. Mike, when you wanted to deploy passive optical networking, can you sort of discuss the sort of challenges and kind of what kind of pushback you had from other people when regarding PON?
Yeah, so I would add to this list is just kind of don't know enough about the technology. I think that's what scares more people away. So it was, my team did not manage the building networks. We actually partnered with the IT group for this project. So some of the pushbacks were, hey, now we're introducing a new device, because for this project we were a Cisco shop, everything was Cisco. And it was just, hey, we can just do it with Cisco and we'll call it a day. But then you started adding it up, you started pricing it out. Because of the amount of fiber and all that, it was just becoming too expensive, and it actually would have probably canceled the security project or the upgrade. But so I think that would be a 5th item I would add on here. It's just not known enough in the real estate market. I mean, your telcos, people who do a lot with that, they understand it. They understand it's been around a while. But it's just it's a lack of education on the options.
Yeah. But of course, that wouldn't apply to anyone on this webinar anymore.
No, exactly. Yeah, so go ahead and show the results for that poll, please. Let's see what everyone has to say. regarding it being a new technology, I'm almost positive at one point fiber was a new technology, just a regular point-to-point, which I'm sure had to catch wind eventually. Right?
Yeah, exactly. I mean, PON is just another fiber technology that's going through that same process, right? Originated as a carrier technology, was incredibly expensive, you know, like fiber optic, oh wow, that's rocket science, right? To the point today where, you know, deploying fiber anyone can do it, right? Passive optical networking is trailing a little bit behind point-to-point fiber on that curve, but not by very much, and it's really starting to get to the point now where it can be applied in virtually any situation for both local areas, campus, as well as, of course, wide area networks.
So Mike, when you talk about when you're adding up the point-to-point Cisco switches, how much savings did passive optical networking bring that specific project? We understand, we see a lot about cabling savings, about 80 to 90%. But overall, what kind of savings were you seeing, if you could put a number on it?
You know, at least 50%. Of course, it also depends on how many devices and how many ports you need at the end of a building. But in some cases, so like the garden style, the 3-story walk-up that we were talking about, I want to say it was close to between 45 and 50%. From a hardware perspective only. I mean, we were already going to have to put fiber in there. It was just how are we connecting it positives. So it was you know, at least 45%.
Yeah. And so that's on capital costs, sort of up to commissioning, but you haven't really factored in ongoing operational costs.
Exactly.
Correct. Yeah.
Yeah. So then with the centralized management, we could even foresee additional savings going forward because of that sort of plug-and-play registration, managing it all from one place. You're not sending a guy running around looking at LEDs on switches.
So another big thing that I kind of want to bring up with regarding to how expensive it is the head-end / core switch. So when we run point-to-point, you're going to need a slot for every SFP. And for every SFP slot, I'm assuming that price is going up for the core switch, correct?
Yeah, if you need to deploy, say, 17 switches, right, each of those needs a home run fiber. And so all of a sudden, my core switch needs to have at least 17 SFPs in it.
Yeah.
And I'm looking at basically a 24-port fiber switch. And that gets very costly.
Yeah.
Right?
Yeah. Exactly. Perfect.
Yeah.
So recognize that. Oh, sorry. Go ahead, Mike.
I was gonna say, yeah. If you don't know what it costs, try to price out. And I won't mention the manufacturer, but a core switch that's FSP only, right? That may have 12 or 24 ports. They're extremely expensive.
Yeah.
And if not, you have to have so many switches because the majority only have 4 or 5 ports in there or 4 or 6 ports for the FSPs.
Yeah, especially when you see the large deployments where they need 50 SFP slots, right?
Yeah.
Like that adds up real quick.
Yeah. And I think that's a bit of a pricing game. Like they'll give you a switch with up to 4 SFPs on it at a pretty reasonable cost, but as soon as you go to what you need for the core switch, it's really going to get you.
Yeah, and to bring it back to passive optical networking, again, Mike's deployments, they were running a single strand of single mode fiber. 1 SFP slot, smaller head end, cleaner and cheaper. So go ahead and close that poll, please. We'll jump back in here. There. Excellent. Now, the great part, the money magic. We have the future of PON. This is not actually a real shot. This is a photo. But Mike, we'll start with you. We know that it's gaining traction here in the United States. Where do you see passive optical networking moving? What kind of industries do you see it taking? And from your perspective, in the next 5 years, how often do you think you're going to see intelligent buildings deploying this technology?
Yeah, so I think that it's been the past 10 years or so that, like, for HVAC as an example, they've started incorporating an RJ45 connection inside, like whether it's a VRF or split system, right? And that's fairly new. And so you're getting companies, whether it's security systems, where that's incorporated now. That's kind of an industry standard. I see the HVAC manufacturers, the security manufacturers, the elevators, all starting to make it where that RJ45 PCM or PCI or whatever it is slot, right, being able to change. So if I have a PON network in my building, why should I have to run Cat5 everywhere? Why can't I connect that fiber connection from that splitter directly in that device? That's where I see it going. And I think you're going to start seeing a few of the larger manufacturers doing it, and then more will start following suit, where you as the building owner or the facility person have an option. Hey, what kind of card do you want in this to manage the system? I think that's where that's going to go, and I think it's going to pick up quicker. You know, the whole IoT and intelligent buildings has just been exploding over the past 10 years. So, you know, you're going to have different ways to connect to it, and I think that's kind of the next phase that I see with the manufacturers. They have to get on board, and it's just going to make this, you know, the PON even more acceptable in the industry. And that's all vertical markets. I don't care if it's, you know, student housing. I don't care if it's campus. I don't care if it's, you know, high-rise, mid-rise, hospitals. Any of that could go to it. I mean, you're already seeing it adopted in hotels more and more. You're hearing more about this. So I think that this is kind of where everything's going. Once those manufacturers get on board, it's just going to take off, and more and more people will start using PON.
No, that's very interesting. So what he's saying is that the end devices, say a camera has an actual SFP that's fixed, that plugs directly from the fiber. That's actually very insightful. I can see that happening too. Erik, getting into the more tech side of things, do we see anything changing, getting greater? Obviously, we see passive optical networking getting traction in general, but as far as, let's say, bandwidth, prices,
so I mean, price obviously continues to come down. Bandwidth, the original PON was G for gigabit PON. There's also 10 gigabit PON is now available. I think that's more being deployed in the carrier market, but we'll look to see 10 gigabit start to come to the passive optical LAN market, eventually reaching intelligent buildings. In terms of 10 gigabit for intelligent buildings, for building automation, it's obviously overkill. It would really only be for video at this point. But what's really cool is that when they designed the 1G and the 10G specs for PON, they were really smart, and they put it on different wavelengths, which means you can actually have 1G and 10G coexisting together on the same fiber. And so if you talk about the future of fiber, the future of fiber is single mode. On a single mode, the physical, theoretical maximum capability of that fiber is 69 terabits, right? So, you know, 10G,
couple cameras on there.
Barely even scratching the surface, right?
Yeah.
So we're going to see, so if you deploy multi-mode fiber today, you're going to be limited by, you know, how much available innovation is on there. If you deploy single mode fiber today, it's virtually endless. We're just getting started with how much technology we can squeeze onto that. But I think in the more immediate future, we're just going to see a wider application of the existing. Just, you know, 1G, Ethernet-based passive optical networking for building automation. We're just going to see more and more deployment of that, just getting into more verticals. That's really where I see the immediate future of PON, is just getting wider acceptance in the market for local and campus area networks.
So just to clarify, when we were discussing multi-mode, can multi-mode use passive optical networking?
So it is not. Passive optical networking is designed for single mode. It is possible to squeeze it onto multi-mode here and there. It doesn't work as well, obviously. There are some distance limitations, but it can be done, but really not recommended.
Well, the splitters don't actually work, right? I mean, the splitters that you showed don't really work with multi-mode either. So.
Yeah, so the splitter is going to be a single mode. What we can do in certain projects, there's been like, well, you know, this link is already there and there's multi-mode fiber available, so we can actually convert the signal onto a multi-mode for a short hop or whatever, and then put it back onto single mode. Again, not recommended, but it can be done in a pinch if we need to take advantage of some existing fiber that's already installed.
Excellent. So going through conclusions, we hope that you grasp the main concept of passive optical networking. Yes, this was built for carrier industry. Yes, when it was built, it was expensive, it was complex, it was hard to use. It's a proven technology, but now it's starting to be tailored and catered towards intelligent buildings. And as you can see with Mike's examples here, it's a very viable and effective solution to bring data to the ends of the projects without having to run a ton of strands, a ton of SFPs, a huge head end. Anything else you want to touch on?
Yeah, no, I mean, I think you got it pretty well. This is a well-established, fully engineered, vastly deployed technology that's now sort of trickling down to more, you know, commercial-grade, industrial-grade applications from a carrier origin.
Yeah. Mike, is there any last points that you kind of want to bring across?
Yeah, no, I mean, I think you kind of hit on it here. I think that the management side gives you, the management side of PON gives you more management, more information than traditional networking. And it's very easy to understand. Again, like I mentioned before, you know, it'll even give you power consumption. So if you know within this range, you can set that up so it notifies you if something's going bad. You know, the ability to reset devices remotely, which I think is pretty crazy. You know, a lot of times you're still tracking things down and having to unplug it. Or what port is that actually connected to on the 48 port switch? That flexibility and that insight into your buildings. Again, to me, from a management perspective, really drives the cost down and helps you, you know, prove this to investors or your building owners or whatever.
Exactly. Yeah. So right now we're going to open up for some questions. So if you have some questions, now's the time to ask. I think we have one on the daisy chain. I'm not seeing it though.
It should be.
It's not there. It's not there. That's okay. So not too many questions. But again, just to address, so Danny Lynch said definitely that the lack of knowledge is really the concern with passive optical networking, which I think all three of us agree with. There we go. How are collisions avoided
We answered that one.
doing the test? Yeah, sure. Perfect, we answered it. So that was our presentation. We hope you enjoyed it. Mike, thank you again for joining us. We appreciate it. Go check out Mike at Whitespace. Again, Whitespace measures the intangibles, not seen so much on the paper when you present it, but these things add up, and Mike's got good insight into that. So thank you again for joining us, Mike. I'm Shane Tacker, the account manager at Optical Networks. With me was Erik Haberger, director of sales. Thank you for joining us. We hope you have a good day. Join us next time in our favorite green room, as always. It's going to be IP Essentials for Operational Technologies at 11 Pacific Time Standard. Thank you again, and have a good day. Thanks, Mike.
Thank you.
Bye-bye.